Hello. Now we have to start applications of AC. So in that article, we have to apply AC to different devices. For example, we have to apply AC to purely resistive circuit, and then we have to study EMF and the current. Similar manner, after that we have to apply it to the capacitor and inductor also, and all the three simultaneously also. So applications of AC to purely resistive circuit. So consider AC is applied across a purely resistive circuit. So this is symbol of AC. So this is a resistor of resistance R. So this is EMF, E is applied. Hence, EMF is given by. So here E is equal to A0 sine omega t, we can write equation number 1. Now we can write the current also. Hence, current through R is. So current. So we know that by Ohm's law, the current is given by voltage upon this resistance. So I can write here by similar way. So I is equal to E by R. So I is equal to E. E is known, E0 sine omega t divided by R. So this E0 is the peak value of the EMF. R is the resistance. Peak value of the EMF divided by peak value means divided by resistance. It gives us a peak value of the current. But here E0 by R is equal to I0. Peak value of current. Hence, we get I is equal to I0 sine omega t, equation number 2. So equation 1 and equation 2 you can see. So both the equations, you can see sine omega t is coming here same. So we can write it here, both the equations are in same phase here. From equation 1 and 2, we have to write some conclusions. So first conclusion is I and E are in same phase. EMF and current having same phase or zero phase difference also you can write. Then we can write here I and E graph. So we can plot a graph also here. So this is 0. Now here this is sine graph. So sine graph we can draw it like this way. So this is the maximum value of EMF, E0. So this is also maximum value of EMF minus E0. This is minimum value 0. Then the current we can draw like this by dotted line. Current is little lesser than this in amplitude wise, I0 plus I0, and here I can write it minus I0. Because here this you can see here current is EMF divided by something, so little lesser current I shown it here. So this axis is omega t. So this is a graphical representation of I and E. Similar manner we can draw phasor diagram also. So phasor diagram I can draw it in this portion. I think this is visible. Phasor diagram. So this is A0 and this is I0, and here it is omega t. So this is a phasor diagram for this purely resistive circuit. So if you want to write it here, you can write this part as a A0 sine omega t. So this is A0 cos omega t or I can write it here E0 sin omega t. Similar manner, we can write the parts of the current also. I0 sin omega t, I0 cos omega t. So both are in same phase here. So you remember the conclusion here. So when we apply AC to purely resistive circuit, so EMF and current, they're having a same phase. So what to remember about phase? Graphical representation and the phasor diagram. That's it.